Hello! In this video we will be looking at Module 2, Lesson 2, adding and subtracting fractions. And what we start with is looking at two rectangles that are both cut into 7 slices. The top rectangle represents 3/7. 3 out of the 7 slices are shaded, and the bottom rectangle represents 2 slices. 2 out of the 7 slices are shaded. Okay, and because the slices are all the same size, both rectangles are cut into sevenths, we can simply add the shaded values together, the shaded parts together. 2 plus 3 is 5, so we have 5/7 shaded. Okay, and that's really what we're looking at here with like denominators. If we think of denominators as units, if our units are the same, if our denominators are the same, then we simply add the numerators and keep the same denominator. Okay, so if we have like fractions, the problems tend to be relatively easy as long as you remember to keep the same denominator. So looking here at number 1, part A, where it says to add and simplify, we're going to add 3/10 plus 1/10. And we're going to make a note that both denominators are the same. They are both tenths. So 3/10 plus 1/10, tenth is 4/10. We add the numerators together and keep the same denominator. Now, the directions do say add and simplify. So when we simplify, as we saw in Module 2, Lesson number 1, we break our fraction up into factors where the numerator and denominator have a common factor. 4 is 2 times 2. 10 is 5 times 2. And there's our common factor of 2 that we can cancel out. And 4/10 is equal to 2/5. Some would say we just divide the numerator and denominator both by 2. You get the same result, 2/5. Okay, there's part A. Now in part B, we're adding actually the exact same fraction, 3/4 plus 3/4. And if they are the same fraction, well, then it would make sense that they have the same denominator. So we're going to keep that denominator the same. The 4's stay a 4. And we add the numerators together. 3 plus 3 is 6. And now 6/4, can we simplify that? Certainly we can. 6 is 2 times 3. And 4 is 2 times 2. Our 2's would cancel out, and we would be left with 3/2. Or we could write that as a mixed number, 1 and 1/2. Now subtracting fractions works pretty much the same way. If we're going to subtract two fractions that are cut into the same number of slices, meaning sevenths in this first example, 3/7 minus 2/7, we simply subtract the numerators. 3 shaded pieces minus 2 shaded pieces equals 1 shaded slice out of the 7. Okay, so with like denominators, again, we think of them as units, and if they are the same, we subtract the numerators, keep the denominators, and make sure we write it in simplest, lowest terms. 3/10 minus 1/10 is 2/10. 3 minus 1 is 2, and we keep the denominator the same. Now we can simplify this fraction. Notice now in all 3 we have been able to simplify. It has to be that last step that you take. You check to see if you can, in fact, simplify. 2 written in factored form is 2 times 1, and 10 written in factored form is 5 times 2. We have a common factor of 2 that can cancel out, so our final answer is 1/5. Don't make the mistake of saying the 2 goes into 10 5 times, so my answer is 5. Right? That would be incorrect. The answer is 1/5. The 5 is actually in the denominator in this example. Now, when we add and subtract unlike fractions, things get a little bit trickier. Okay, if we want to add 3/7 plus 2/5, what we have to notice is that 7 and 5, those denominators are different. So if we look at the rectangles, the slices are different sizes from the top rectangle to the bottom rectangle. If they're different size slices, we can't just simply add them together and say that there's 5 out of something. A common mistake here is that students will add the numerators and add the denominators. That is completely incorrect. Okay, the pieces are different sizes, so to get pieces that are the same size, we need the same denominator for each fraction. We do that by finding the least common multiple of the denominators. Now, it's okay to use any multiple if you want, like a bigger common multiple, but the least common multiple gives us the best, the smallest numbers to work with. Okay, we write an equivalent fraction using that least common multiple, and then add or subtract and simplify. So looking at number 3a, we're going to add 3/8 and 1/5. So the first thing to notice is that those denominators are in fact different. And the least common multiple for 8 and 5 is 40. Now I could do that by counting up by 8s, 8, 16, 24, 32, 40, and 5s, 5, 10, 15, 20, 25, 30, 35, 40. Or in this case, it works to multiply 8 and 5 together. Okay, so now to get that equivalent fraction, we're going to take our first fraction, 3/8, and multiply it by 5/5. Now, if we remember back to lesson 1 in this module, to multiply fractions, we multiply the numerators. 5 times 3 is 15. And we multiply the denominators. 5 times 8 is 40. Okay, and I'm writing that off to the side because I still need to get a common denominator with my second fraction. Okay, in the second fraction, we're going to multiply that 1/5. 1/5 times 8/8. Now, by using 8 over 8 and 5 over 5, we're really just multiplying the fractions by 1. Right? 5 divided by 5 equals 1, 8 divided by 8 equals 1. So we're not changing the value of the fraction, we're just essentially cutting the rectangle into more slices. Okay? That second fraction becomes, well, 1 times 8 is 8 in the numerator. 5 times 8 is 40 in the denominator. And now we do have our common denominator of 40. So we can simply add the numerators together. 15 plus 8 equals 23. And our common denominator stays the same, and it is 40. Now 23 is actually a prime number, so even if I were to try and simplify this fraction, I wouldn't be able to. They're not both even, and no other number divides into both 23 and 40. So that problem is done. It just so happens that this one we didn't need to simplify. Okay. In part B, 3/8 minus 1/5, it's going to work out roughly the same steps, right? We need to get a common denominator. Now, notice the similarities between A and B. Both fractions are 3/8 and 1/5, so that didn't change. So this is going to work out almost the same. So we're going to take our 3/8 fraction, multiply it by 5 over 5, and we're going to take our 1/5 fraction and multiply it by 8 over 8, the same way that we did before. 5 times 3 from the first fraction is 15 over 40, and 1 times 8 from the second fraction is 8 over 40. And then our result here is, let's see, oops, I was writing an addition sign here the whole time. So let me rewrite this as subtraction. 3/8 minus 1/5. 15 over 40 minus 8 over 40. And when we subtract those two fractions, we subtract the numerator. 15 minus 8 equals 7, and we keep the denominator the same, 7/40, or 7 over 40. Now, in this final part of the lesson, we're going to add and subtract mixed numerals, or mixed numbers. And the directions here say to first take care of the fractional parts, and then the whole numbers. And that's exactly what we're going to do. We're going to start with the fractions, and I'm even going to kind of pull them off and write them off to the side, and then bring it back and add the whole numbers together. Okay? And we have to be careful of also is carrying and borrowing when we need to. Okay? So we'll start with part A, 12 and 5/6 plus 4 and 7/12. And I'm just going to take the two fractions and write them off to the side. 5/6 plus 7/12. We can add the fractional parts together first. And in order to do that, we're going to follow the same steps that we've been following in that we need a common denominator. Now our common denominator here, 6 and 12, what do they both have in common? Well, 12, right? Your least common denominator can, and occasionally will be, one of your two denominators. So all I need to do here is change the first fraction and change that by multiplying it by 2 over 2. That's going to get my denominator to be 12. So 5/6 becomes 10/12. 2 times 5 is 10, and 2 times 6 is 12, plus 7/12. Now that my denominators are the same, we can add our numerators together and get 17 over 12, or 17/12. Now, because we're adding mixed numbers together, right, I want to rewrite my solution here, not my solution, but part of my answer, to a mixed number. 17 over 12, that is 1 and 5/12. Now, how did I come up with that? We're rewriting this improper fraction as a mixed number, right? And 12 goes into 17 once with 5 left over. 12 plus 5 equals 17. So it went into 17 one whole time with 5 left over. All right, now I'm going to bring that 1 and 5/12 back into my original problem here. Ooh, I didn't mean to cross it out. Back into my original problem over here. And 12 and 5/6 plus 4 and 7/12, we know that the fractional parts add to 1 and 5/12. And we still have the 12 and the 4 to add together. Well, 12 plus 4 is 16. And now 16 plus 1 and 5/12 is 17 and 5/12. And that's how we can finish that problem. Okay, so it's a few more steps, right? We kind of pull the fractions off to the side, rewrite them, and add them together, and then bring it back to the original problem. In part B, where we're subtracting, one thing that we're going to have to often do is, as it says in the directions, borrow when necessary. Okay? In this one, now how do I know that I have to borrow? Well, looking at my two fractions, 5 and 1/12, 3 and 2/3, if we're going to subtract the fractional parts, 1/12 is smaller than 2/3. So we're absolutely going to need to borrow 1 from the 5 in order to subtract the fractions. Okay, and that is our first step. So 5 and 1/12 can be written as 4 and 13/12. Now, how did I do that? Well, I borrowed 1 from the 5. Borrowing decreases it. It became 4. And I added it to the 1/12. Okay, now I'm going to show this off to the side. This is something that if you wanted to or if you needed to, you could certainly show it. But if I'm going to add 1 plus 1/12, that's the same as adding 12/12 plus 1/12, which is equal to 13 over 12, 13/12. So that's where that 4 and 13/12 came from. And it's absolutely necessary in order to do the subtraction. Again, because 1/12 is smaller than what is being subtracted from it. Okay, so I'm going to finish writing the rest of this problem. 4 and 13/12 minus 3 and 2/3. And now we can go about it pretty much the same way that we just did. We're going to pull off the fractional parts. 13/12 minus 2/3. We can get our common denominator, in this case, 12 and 3. Well, they have 12 in common as their least common multiple. 3 times 4 is 12. So that second fraction needs to get multiplied by 4 over 4. I'm going to rewrite my first fraction, 13 over 12, minus 2 times 4 is 8 in the second fraction, and 3 times 4 is 12. And that's exactly what we want to see. Common denominator. Okay, and we added the numerators together, or subtracted the numerators together. And we rewrote the numerator. 2 times 4 is 8. Now we can actually do the subtraction. 13 minus 8 is 5. And we keep our denominators the same, 5/12. Okay, so we've subtracted the fractional parts. So now we can bring that back over into the original problem over here. Okay, and we know that 4 minus 3 equals 1, and the fractions subtract to give us 5/12. So we have 1 and 5/12 as our solution. Now in part C, we're subtracting 5 minus 2 and 1/3. While this one may look like it's more challenging because the first term does not have a fraction with it, it actually, I think it's going to end up being a little bit easier than the first two. Okay, we know that we're going to need to borrow because our first fraction, or excuse me, our first number, mixed numeral, does not have a fractional part. So if we're subtracting 2 1/3 from 5, we need that 5 to have a fraction with it, so I can subtract the 1/3 from it. So we're going to borrow. All right, we're going to rewrite that 5 as 4 and, well, plus 1, but if I want to write that as a fraction, I'm going to write it with the same denominator as my second fraction, 4 and 3/3. 4 and 3/3 is the same number as 5, right? 3/3 is 1, 4 plus 1 is 5. And by using 3/3, we're not going to later on have to get a common denominator. So we're subtracting 4 and 3/3 minus 2 and 1/3. Now we can off to the side take our fractions off. 3/3 minus 1/3 already have a common denominator. That's equal to 2/3. So we've taken care of the two fractions, right? 3/3 minus 3/3 minus 1/3 is 2/3. And now we can subtract the whole numbers. 4 minus 2 is 2. And our final answer to part C is 2 and 2/3. This brings us to the end of Module 2, Lesson 2. Thank you.